Today, we're jumping into something really cutting edge, decentralized infrastructure. We're looking at how it's powering what comes next.
Yeah, we've got two different angles on this. One's about boosting AI using the blockchain, and the other's about, well, harnessing GPU power everywhere for things like rendering.
Exactly. So first, we'll look at Theta Edge Cloud. They've just announced these things called agentic tools we're pulling from their recent blog post.
Right. And then we'll switch over to the render network. We've got their white paper so we can really get into the nitty-gritty of how they work.
And our mission here really is to understand how these platforms are trying to, open up access to powerful tech. What does it mean for you if you're a developer, an artist, or just trying to figure out where this is all going?
Yeah, what are the actual implications?
Okay, so let's start with Theta Edge Cloud. Agentic tools, what's the big picture?
Well, Theta Edge Cloud wants to be the place, the decentralized cloud for AI, media, entertainment. That's their big goal.
Mhm.
And these agentic tools are a major step toward that. They're basically AI tools built on Edge Cloud to help developers build on Theta.
Right, making it easier, more powerful for people already in their ecosystem.
Exactly. It's all about using large language models, LLMs,
Mhm.
but giving them more.
More than just generating text, I assume.
Yeah, way more. See, LLMs are great with language, but agentic tools let them connect to the outside world. Think APIs, databases, running code, calculations.
Ah, okay, so the AI can actually do things, interact with systems.
Precisely. Pull real-time info, execute tasks, even generate images. It's like giving the language model hands and eyes on the digital world.
That sounds powerful. It leads into this idea of agentic AI workflows then. What does that look like?
It means AI that's more autonomous. Agents that can reason and act,
Hmm.
assistants that could potentially build an app for you or analyze data.
Build an app. Wow.
Yeah, or like domain-specific systems that mix language smarts with external knowledge. The key is they can initiate actions, not just respond.
That feels like a real leap. Now, the blog post specifically talks about using these tools with ARG chatbots. ARG is retrieval augmented generation. How do the tools improve that?
So, standard Argon pulls info from a data set to answer you, right?
Right.
Agentic tools give that RGAG bot superpowers. Instead of just static info, it can actively search the web for current data, call APIs, run code, mess with documents.
So it's not just finding info, it's investigating. It can go out and fetch, calculate, interact.
Uh,
What's the benefit for developers building these things?
Speed and power, basically.
Hmm.
Faster prototyping because they have these tools ready or they can customize them. And the apps they build are just way more capable. Imagine an assistant that doesn't just chat but actually automates complex tasks by talking to other services online.
That's compelling. And they mentioned custom tools too, so developers aren't just stuck with the built-in ones.
Not at all. Custom tools let developers connect to pretty much any API they want. They define when the chatbot should use it, what info it needs. Total control.
Okay, the examples help. They talk about using a GT request that's for fetching data with the Blue Sky API. How would that work?
It's pretty straightforward, actually. In the Edge Cloud setup, you'd add a new tool. You tell it, in plain English, basically, use this when someone asks what's trending on Blue Sky.
Okay.
And then you select GTT, paste in the Blue Sky API, address the endpoint, save it, and you're done. You've taught the AI a new trick.
So then I could just ask the bot, hey, what's trending on Blue Sky? And it would.
Yep. It recognizes your question, uses that tool you set up, queries Blue Sky, gets the trends, probably summarizes them, maybe gives you links, all automatic.
That's pretty slick. They also had a PDOST example sending data for deploying a Jupyter notebook. That sounds more complex.
A bit, yeah. POC requests often involve sending data to a service. So you still configure the when and the API endpoint, but you might also need to add things like an API key in the headers for authentication.
Right, security.
And in the body, you define the data you're sending, usually in JSON format. It's like filling out a form the API understands.
So for the Jupyter notebook, I could just ask the bot in plain English, deploy a notebook for me, and the custom tool handles the technical POSD request.
That's the goal. The bot translates your request, uses the tool, sends the command via the API, and boom, you get back a link to your running notebook, maybe even the tech specs.
And PUT requests for updates work similarly.
Okay.
What about the built-in tools? What do they offer right away?
Immediate utility. There's web search, obviously useful for getting up-to-date info. And text to SQL is really interesting.
Text to SQL.
Yeah, it turns your normal English questions into SQL database queries. So you could ask, like, show me sales figures for last quarter, and it generates the code to pull that data. It makes databases way more accessible.
That is useful. Okay, looking forward, they mentioned something called MCP Model Context Protocol. What's that about?
MCP is trying to be a standard, secure way for AI agents to connect to any external tool or data source. The analogy they used was like USB-C for AI.
Ah, universal connector. Makes sense. So any AI could plug into any tool.
That's the vision, interoperability. And then it's thinking about building an MCP marketplace on Edge Cloud.
A marketplace?
Yeah, where users could maybe run MCP servers on the Edge Cloud network using Theta nodes or community nodes.
Hmm.
And get this, the nodes running these servers could potentially earn tokens for doing it.
Interesting. Incentivizing the infrastructure for AI tools itself. Very cool. Okay, let's pivot now. Let's talk about render network. Decentralized GPUs.
Render Network's big mission is democratizing digital creation, making the tools, especially high-end rendering power, available to everyone. They want this open ecosystem for 3D assets.
And the white paper starts by highlighting a problem. Computing infrastructure is a bottleneck, especially for next-gen stuff like VR, AR, AI.
Exactly. The demand for GPU power is just exploding. Complex visuals, immersive experiences, AI models, they all need serious horsepower. Centralized cloud GPUs exist, sure, but they can be really expensive and access isn't always guaranteed. It holds creators back.
Especially smaller studios or individual artists, I imagine.
For sure. And this bottleneck only gets worse as things get more complex. So Render Network's solution is elegant, really.
Which is?
Tap into all the unused GPU power sitting idle around the world. Connect the creators who need rendering power with the people, individuals, businesses who have GPUs just sitting there doing nothing.
A peer-to-peer network for GPUs. Okay, what's the value prop? Why would creators use it, and why would people share their GPUs?
For creators, it's simpler, potentially cheaper access to massive rendering power. They can farm out complex jobs across this huge network. For the GPU providers, the node operators, they earn RNDR tokens for contributing their processing power.
RNDR. Okay, so it's a marketplace.
Right. It makes hardware use more efficient and creates this marketplace for digital ideas and compute power.
The white paper lists a ton of use cases. It goes beyond just film VFX.
Oh yeah, VFX and motion graphics are big, especially for indie creators who couldn't afford render farms before. But also virtual assets, NFTs with provenance, virtual production where you mix live action and CG in real time, plus architectural visualization, product design, scientific simulations, basically anything needing heavy GPU lifting.
And they're looking at AR, gaming, AI too.
Definitely. For AR/VR, think pre-rendering super detailed environments or even streaming complex graphics. For AI, the network's decentralized GPUs could be used for generating 3D content from text, speeding up AI rendering techniques, running inference, even training models, possibly with built-in rights management.
Okay, let's get technical. How is the render network actually built? What's the architecture?
It's kind of two layers. There's the off-chain network, where the actual rendering work happens. That's the creators, the node operators, the render network platform coordinating things, and the software vendors.
So the heavy computation is off-chain.
Right, for speed and efficiency. Then there's the blockchain layer. That handles payments using the RNDR token, uses smart contracts for escrow, and ensures everything is verifiable and trustworthy.
Makes sense. Keep the computation fast, use the blockchain for trust and value exchange. They mentioned Octane Bench. What role does that play?
Octane Bench is their own tool for benchmarking GPU rendering speed. It gives a score, OBH Octane Bench points per hour. This is crucial because it standardizes pricing.
Ah, so you know what you're paying for in terms of speed.
Exactly. It provides a common metric across all different kinds of GPUs on the network, feeding into their multi-tier pricing system. It keeps the marketplace fair.
And how do they build trust in this peer-to-peer system? Reputation must be key.
Absolutely. Both creators and node operators build reputation. Nodes get points for completing jobs successfully and on time. Creators get points for being reliable users. Higher rep can mean faster job allocation for creators or more jobs assigned to nodes. It encourages good behavior.
So when a job comes in, how does it get assigned to a specific node operator?
It's a two-step process. First, job allocation looks at the creator's rep, the job complexity, and how many GPUs are free. Better rep means you might run more jobs at once or get priority. Then, node allocation matches a job to specific nodes based on the pricing tier chosen, hardware needs, node uptime, both reputations, and that Octane Bench score. It tries to find the best fit.
Sounds quite sophisticated. What about security? Sending valuable assets across a P2P network?
Yeah, they've thought about that. Rendered outputs are encrypted, assets stored temporarily or encrypted, frames get watermarked until payment is confirmed, and they try to minimize how long assets are stored on nodes.
And for developers wanting to integrate with Render, there's an API and SDK.
Yep. The API lets third parties build apps on top of render. You could create custom rendering pipelines, maybe swap textures in a scene without re-uploading the whole thing. The SDK will likely enable even deeper integrations.
ORBX file format. Sounds important. What is that?
Or RBX is key. It's an open container format. Think of it like a zip file for a 3D scene. It bundles the geometry, textures, lighting, everything, plus the instructions on how to render it. Crucially, it works with lots of different 3D software.
Software agnostic. That's big for a distributed network.
Exactly. You don't need everyone on the same software. Plus, the render instructions, the graph, inside the ORBX file are cryptographically hashed. That gives you provenance, a traceable history of the assets and the work done. Super important for NFTs and ownership.
And it's becoming the basis for this immersive technology media format.
Yeah, potentially a big standard for future immersive content. They also mentioned multi-render support is planned. What does that unlock? That's huge for artists. It means Render Network won't just be for Octane render. They plan to support other major engines like Redshift, Arnold, Blender cycles.
Oh, wow.
So artists can use their preferred tools on the network, though there might be extra license fees passed on for some of those engines.
We touched on render and AI. How do they see that connection strengthening?
They see a real synergy. The network's GPU power is great for AI tasks, generating 3D from prompts, AI denoising, inference, maybe even training. They're looking at integrating AI tools into creative workflows and using the blockchain for things like licensing 3D models used for AI training.
Great. Provenance for training data.
Now let's talk money. The burn and mint equilibrium BME. How does that actually work?
Okay, the BME. It's their economic engine, rolled out with RMP 0001. Basically, jobs are priced in fiat, like US dollars.
Priced in dollars, okay, but paid how?
Creators can pay in fiat, or the equivalent RNDR. When the job's done and approved, the protocol takes the fiat amount, uses 95% of it to buy RNDR on the open market, and then burns those tokens, removes them permanently.
Burns them, okay, and the other 5%?
Goes to the Render Network Foundation for operations. Now, that's the burn side. The mint side is the creation of new RNDR tokens. These are emissions, basically rewards. They go to node operators for providing GPU power and completing jobs. A small bit goes back to creators as rebate, and some goes to liquidity providers. So demand for rendering burns tokens, potentially reducing supply, while rewards mint new tokens to incentivize participation. It's like a balancing act.
Exactly. It aims for a stable, self-regulating economy tied to actual network usage.
Let's quickly jump back to Theta's underlying tech from their white paper, just for comparison, their consensus mechanism.
They use something called multi-level BFT. Small group of validators proposing blocks fast. Larger group of guardians finalizing them at checkpoints. It's layered for speed and security.
And for video streaming, their micropayment system.
The resource-oriented micropayment pool. It's mostly off-chain. You set up a pool, people draw from it for watching bits of video via off-chain transactions. Super fast, scalable for tiny frequent payments, avoids clogging the main chain, and has anti-double spend measures.
They also mentioned storage optimization.
Yeah, modular ledger design for scaling, supporting different databases, and history pruning to reduce storage needs for nodes by cleaning out old, unneeded transaction history. Plus, efficient sync for new nodes. They don't need the whole history from day one.
And Theta's dual tokens, Theta for staking governance, Theta Fuel, TFUEL for transactions.
Yep, separate security incentives from operational gas fees.
Okay, wrapping this all up. We've covered a lot of ground on two very different approaches to decentralized infrastructure. What are the big takeaways?
Well, both are tackling huge resource needs for future tech, right? Theta is very focused on optimizing its chain for AI and media, building specific tools like agentic tools. Render Network is building this massive, specialized marketplace just for GPU power.
What were the aha moments for you?
For Theta, definitely the agentic tools concept, giving LLMs real-world capabilities, especially for RAG. That feels like a glimpse of the future for AI apps. For Render, the BME model is just really clever, tying tokenomics directly to real-world usage and value in such a dynamic way.
Yeah, definitely some cool innovations. What questions do you think this leaves us or our listeners with?
Oh, loads. How will these platforms keep up? We need to see real-world performance, adoption numbers, and how will these different token models play out long-term for everyone involved, users, node operators, investors. Those are the big ones for me.
Absolutely. So the final thought to leave you all with. As this insatiable demand for compute just keeps growing, are decentralized models like Theta's and Render's the key? Are they what unlocks that next wave of creativity and innovation we're all waiting for? And maybe what part will you play in how this all unfolds?